So I'm just recording the sessions. Okay, I'll make sure that I put it in a drive and I'll share you the drive link. So in case if any one of you miss the sessions or you want to go through it again, you can make use of it.
Yes. Okay.
Okay, ma'am. Thank you.
Yeah, okay.
Yes. So yesterday, this is where we stopped in. So we were discussing like what are the key features of our Java programming language. So what makes Java so special? So out of this, we are going to be discussing mainly about some features like the first one, platform independence. So platform independent and architecture neutral. These two are the most important points among all this. So this is going to be our primary focus to start with. So now the first thing is people who are little familiar with our C programming. Okay, now in that we have some data types. For example, like something called as an int. So int data type, it represents integers. So integers means numbers. So numbers, that too specially whole numbers. That is no fractional or no decimal values. Whole numbers are what is called as an int. So int is one of the most popular data type. For example, I want to store my age. I want to store my mobile number. So for all those things, I will be making use of this int data type. So whenever you create an int data type, it allocates some memory. It allocates some memory space because we are going to store some value. And whatever we are going to store, it always uses some memory space. For example, I'm taking a selfie in my phone. That also is going to occupy some memory space. Same way, whatever data I am going to store, that requires memory spaces. So how much of memory? How much of memory needs to be allotted? That is decided based on the data type. So based on what type of information I am going to store. Am I going to store a number? Okay, if it is a number, is it a whole number or is it a fractional or a decimal value number? Or am I going to store a single character? Or am I going to store a group of characters, like for example, my name or my email ID, my address? So all those things are group of characters. So like that, depending on the type of information that we are going to store, memory space is allocated for us. So let us take an example of an int which represents an integer, or rather to say whole numbers. So in C language, so when we talk about a C language, in C language, the memory of an integer depends on the system. How much of memory this is going to occupy, it actually depends on the system configuration. That is, depends on the architecture of the system. For example, if my system is a 16-bit or a 32-bit system, then int data type will occupy 2 bytes of memory. So depending on the system's architecture, the memory is allocated. For example, as I said, if it is a 16-bit or a 32-bit system, then the memory space given for an integer is 2 bytes. If it is a 64-bit system, if the configuration of my laptop or my computer is a 64-bit system, then this data type int, it occupies 4 bytes. So that is, my system configuration also plays a role in my programming in languages like C or even C++. But this is not the case with Java. That is the reason why we call Java as architecture neutral. So no matter what your system configuration is, whether it is a 16-bit, 32-bit, 64-bit, whether it is having it's a i3 processor, i5, i7, whatever it is, immaterial of my architecture, everything is a standardized version. All my data types, everything is going to be a standardized versions. So there will not be any changes. So that is one very, very important features in my Java. So it is an architecture neutral programming language. So system configuration does not affect my program in any ways. The output of the program is going to be same no matter in what system you're going to execute it. That is point number one. Point number two, platform independent. Another very important and key feature of Java is the concept of platform independency. So now we have to understand what do you mean by this platform independency. Right. For that, basically, let us try to understand how a program is actually getting compiled and executed in a normal sense. For example, again, other than Java. So let us take an example of C or C++. So in C or C++, basically, any program, okay, any program that you're going to execute is having a two-step process. So any program execution is a two-step process. That is, your step one is going to be the compilation. And step two is going to be the execution, or what we call as running. Okay, so or what we say as run the code or running the code. Right. So basically what happens here is the program that you are going to write. That is the instructions. The instructions that we are going to give, that is our program, is called as a source code. So the first step is we are going to create the source code. That is nothing but the instructions. We are going to write it in either C language or C++, any programming language we are going to write. This source code will have the file extension as .c if it is a C programming. So let us take it as a C program. Okay, so it is going to have the file extension as .c. So you're going to give some file name, some name for that file. Then I'm going to say .c. Save the file with this name. Right, done. So first step is done. So I have written the instructions. Now, what will happen to these instructions? As we all know, we are writing the code in a high-level language, which is understood by the programmer, but not by my computers. So I have to do the converting process. So the next step, what I'm going to do is a step which is called as compilation. So the process or the step is what we call as a compilation. So here in the process of the compilation only, my compiler is going to do the syntax checking. So it is going to check for the syntax. If everything is correct, then it is going to convert this into something what we call as an object code. So here, once the compilation is done, what I'm going to be getting as a result is called as an object code. So an object code is nothing but the mission code, zeros and ones. So the file which is going to get converted into an object code. So object code will be having the same name as that of the file name. Here we have given a file name. So object code also will have the same name, but the file extension will be .obj. The file extension, the type of file it is going to create is an obj file. So that is why we call it as an object code. So now execution. This object code is going to get executed for us. And then it is going to produce the required output. So this is the basic steps that happens in the background. So for example, you're taking C program or you're taking C++ program, the basic step what happens in the background is this. So we are going to write the instructions. The instructions that you're going to write is called as a source code. So what you're going to do, you're going to give a name for that file. You're going to save it with the file extension. So file extension, depending on the programming language. So it is going to be either C if it is a C program, CPP if it is a C++ program. So like that, it is going to differ. So then what we are going to do, we are going to start the process of compilation. So what is this compilation going to do? First, it is going to go for the syntax checking. So if everything is correct, then it is going to convert my source code into something which is called as an object code. So the object code is nothing but a converted binary file. So it is going to have the same file name, but the file extension is going to be .obj. This object code, when you run the program, when I execute the program, so this object code is what is going to get executed. So this is going to get executed and we are going to be looking into the output. So this is the step that is going to be happening for us. Right. Now, the main point what you have to understand is this object code that is getting created is a mission dependent code. So your obj file that is getting created is a mission dependent file. So now what do you mean by this term mission dependent is for it to execute, for the file to execute and for us to see the output, I require the support of my operating system. So I need the support of my OS based on my system's configuration, based on the OS that is running in my system. So according to all this only, this object file will get created. So it is a mission dependent file. Now, for example, I have created the program. I want to give the program to you. I want you to run it and see. But what I have to share is I have to share you the source code itself. I cannot share you the object code because the object code that has got created in my system is meant for my system's configuration only. So it cannot directly get executed in your program, in your system. So what I have to do, I have to share the source code to you and you have to compile the source code again, create a new object file and execute that file in order to see the output. So that is what you mean by a mission dependent files. So this is what happens in my C and C++ programs. Hence, this was broken by my Java. So this concept was entirely broken by my Java. So Java was able to create platform independent programs. Platform independent applications we were able to create with Java. So for Java, we call it as ORA, WORA, which means write once, run anywhere. You just have to write the program, write the code once. So once you have compiled the program, once you have created the file, then there is no need for you to compile it again and again and again. If you are making some changes to the source code, then yes, we have to recompile it. But otherwise, it is not necessary. The file that is getting generated can directly be executed no matter what platform you're going to execute it in. Write once, run anywhere. That is the core foundation of my Java. Now, the term platform here generally refers to the operating system. So, whether I'm having a Windows or my company, the one where I'm going to make the software and give for my client. My client is a very security freak. So he says, I'm use only Mac. I don't want Windows or something. So I want my application to work in a Mac laptop or a Mac system. Or some of my other clients are there who are using Linux. So the operating system used by different people may be different. It's not necessary that everybody will be using only Windows. So it is not feasible for us to create one separate application for Windows, one separate application for Linux, or one separate application for Mac. No. So your application should be able to get executed in the same manner. That is, output should not have any differences, no matter what platform it is, no matter what your system's architecture is. So that is what is achieved with my Java. And this is the concept of write once, run anywhere. So now we have to understand how Java is able to achieve this. How are we able to get this platform independent feature? So here also the same step is followed. I am going to write my source code. So here also source code. Now source code is going to have the file extension .java. Okay, so for any Java file, you're going to give the file extension as .java. Right. So now, sorry. The next step, what is going to happen? Same process, compilation. Same process, compilation. Now, I told you yesterday, I hope you remember, Java uses both compilers as well as interpreter. So for the process of compilation, I am going to make use of a compiler. So the name of the compiler that I am going to be using is called as Java C. Java C is my Java compiler. So what is this compiler going to be doing? Okay, this compiler is going to convert my source code. Okay, whatever the source code I'm having, that is my high level programming code. It is going to convert my source code into something called as bytecodes. We call it as bytecodes. Remember, in Java, directly object code is not created. In Java, directly object code is not created, but it rather creates an intermediate code. We call the bytecodes as an intermediate code. So it is neither completely a high level code, nor it is completely a zeros and ones. It is somewhere in between. So that is the reason why we call this as an intermediate code. Now, this bytecode is also known as dot class files. Please remember, another name by which we refer to this bytecode is dot class files. The reason is because this file is going to have the file extension as dot class. So that is the reason why this bytecodes is also called as a dot class file. So remember the same file name. The same file name what we have given here. This also is going to have the same file name, but the file extension is going to be dot class. So now what is the advantage of this bytecodes? The bytecodes that is getting created is a platform independent code. Very, very important is this bytecode is a platform independent code. Remember what I said. The object code that is getting created in my C or C++ is a mission dependent. That is, it requires your operating system support to get executed to see the output. But here in our scenario, in our Java scenario, the bytecode that is going to get created, the intermediate code that is getting created is a platform independent code. That is the reason why my Java is able to achieve this feature. Okay, now when I execute the program, this bytecode is what is getting executed. And this execution part is done by my interpreter. So please understand, the compilation part is done by my compiler, and this bytecode to my output. Okay, bytecode is getting executed. So when it is getting executed, it is going to get converted to an object code, and then the output is going to get generated. And then my output is going to get generated. This process is done with the help of an interpreter. So who's going to take care of this? My interpreter. So bytecode to the mission code conversion is done by the interpreter. Source code to bytecode conversion is done by my compiler. So that is why I said Java is one programming language which makes use of both my compiler and my interpreter to execute the program. Right, so this is the working environment of how my Java application is able to achieve this. Now remember what I said. Now I have created a Java program. Again, I want to share the Java program with you. That is, I want you to execute it and look at the output. So here what I can do, there is no need for me to share you the source code. I don't have to reveal my code at all to you. What I want you to do, I want you to just execute the program. Just run and see, look how the output is coming. For that, no need for me to share you the source code. What I can share you the bytecodes. I can directly transfer you the bytecodes, the intermediate code. So you can run the bytecode and look at the output of the program. Because the bytecode that is getting generated is a platform independent code. No matter whose system it is running, it is going to produce the same output as for everyone. So this is the concept of my platform independency in Java. Now, again, my question is how this is getting done. So when you install Java, whenever you're going to install Java, there are some technical jargons that we will be using: JDK, JRE, JVM. These are the three important things that you will be knowing when you're installing a Java program or Java file. Installation of Java software. Now, please remember one thing. If you are a developer, okay, if you are a developer, that is, you want to create a Java program, run it, test it, see the output, do the modifications, corrections, everything, then you can install the complete Java software. That is nothing but my JDK. So JDK is the complete Java software that you're going to be getting. So JDK is called as my Java development kit. So this is the entire software of Java is there within my JDK. All the predefined library files, all my running environment, everything will come along with my JDK itself. The Java documentations that is available. So everything. So once when you install your Java, just go to your C drive where the program, where the file is present, and just open your JDK and see. You'll be able to see a lot of different files, your documentation files, your library files, all the predefined things, everything, including your JRE, everything will be present inside the JDK itself. So as a developer, JDK is what you're going to be installing. But think, if you're a client, you're not going to create any Java application. I'm just going to run my Java program. I don't want to type execute Java program. I don't want to create a Java program. I just want to run the program. So if you just want to run a program but not create it, then JRE is sufficient. There is no need for you to install the complete JDK also. You can just install the JRE alone. That is, I just want to run the program, see the output. I don't want to do any modifications. I don't want to touch the source code, do any changes. Then JRE is sufficient. So what is this JRE? JRE is nothing but Java Runtime Environment. So JRE is nothing but my Java Runtime Environment. So when JRE is getting installed, JVM is part of my JRE. JVM is a part of my runtime environment. So what is this JVM? JVM is what we call as a Java virtual machine. Java is able to achieve this platform independency feature because of the presence of my JVM. So JVM, so first time when you're going to download and install your Java application, what we do, you go to the Oracle site. So there you're going to say, okay, download Java. So there it is going to ask you, okay, what is your system's configuration? Is it a 64-bit system? Is it Windows? Is it Mac? Is it Linux? So it is going to ask you all those details. So according to your system, whatever the configuration or whatever it is, you're going to download and install the JDK application. According to that, you're going to download and install your JDK. So along with my JDK, my JRE is part of it. Inside my JRE, my JVM will automatically come. So please remember, Java virtual machine is a platform dependent one. That is not platform independent. Java application will get installed according to your system's configuration only, according to your operating system only. Now, once this virtual environment is installed, okay, in your laptop or in your system, once this virtual environment is installed, your entire running code execution of the Java will happen inside this only. So there will be no direct contact between your application and your operating system. Everything is taken care by my JVM. So your program is going to run inside the JVM. So whatever is the operating system support is required, my JVM will take care of it. I don't have to bother about anything. So that is a discussion going on between my JVM and my OS. That's it. So that is why it is able to achieve this platform dependent, because everything is running in my JVM, and JVM is a standard version. JVM is standard for every OS or for every platform. JVM is standard. So that is how it is going to be running. So any Java application you're creating is going to get executed inside a virtual environment, which is called as my Java virtual machine. So this is how my Java is going to be working, or the simple background concept of how you are going to create a program and how the program is going to get executed. So this is a two, as I said, very important features of platform independency and architecture neutral. Right, now I used one more word, one more feature I said when I was typing the things yesterday. Portable. Portable. So the software that you're going to be creating should be portable also. Sorry. The portability of Java is achieved with the help of these two concepts only, because of the platform independency and because of the architecture neutral. So portable means these two concepts together. These two concepts together is what we call as portable. So portability in the sense, suppose today I'm running the program with something. Tomorrow I want to migrate. I want to upgrade my system. I want to migrate my operating system, whatever it is. The application that I am creating should be able to adjust itself in any sort of environment. So that is what you mean by the concept of portability. So Java is a portable application also. So because of these features, it has this advantage also. Right. Now, some other features, what I was telling you yesterday. Among that, very, very important, another one is robust. My Java applications are always robust. Now, what do you mean by this robust? The application that you are going to be creating should not crash, should not fail. So your application should be secure. So how Java is able to achieve this security? So here Java is doing this security feature in two different ways. Java is securing my program in two different ways. One is during compilation. One is during execution. Java, every Java program, okay, every Java program that I execute is basically undergoing a two-step security process. One process is done during compilation. Second process is done during the execution of the program. So during the compilation, what happens? My compiler is going to take care of that. What it is going to take care? Please remember, Java is a strongly typed language. Another terminology that we use for Java is that Java is a strongly typed language. Now, what do you mean by this? I'll come and tell you. Just give me a minute. I'll tell you about that. So when you're going to run the program, your compiler, that is when I'm going to compile the program, the compiler is going to do my syntax checking. Whether you are following the rules and regulations of the language. So that checking is done by the compiler. Now, when I am executing the program, when this process bytecode to object code execution is happening, here again, another step of compilation, another security check is done. That is by my bytecode verifier. This step of process is called as done by the bytecode verifier. Now, what is the bytecode verifier going to do is, it is going to check whether there has been any changes to this bytecode. So first time when the bytecode is getting created, and now when you're executing the program, is there any changes in the bytecode? Has the file got corrupted or anything has been added to it or deleted from it? So what is the changes that has been done? It detects the changes. So if the bytecode has been modified, or if the bytecode is not the same as what it did the first time when it compiled, then it will not allow the program to execute at all. So any changes in the bytecode, your program will not get executed. So this is another way of cross-checking whether my program is having any issues or not. So one-step process during the compilation, one-step process during the execution. So it makes sure as far as possible, let us try to keep my program from crashing whichever way it is possible. These are just additional tools. Other than that, we do the testing also in the code. As a programmer, we do lot of testing in the code also. That is another one. So this is another thing that is done by my Java. So as I said, Java is a strongly typed language. So coming to that point, what do you mean by that? So here there is one thing you have to remember, that is any programming language you take, any programming language, majorly they fall under two categories. Any programming language majorly falls under two categories. What are the two categories? It is either going to be statically typed or it is going to be dynamically typed. So any programming language we take for that matter, which is currently there, any high level programming language will definitely come under either of these two categories. Either it is going to be a statically typed language or it is going to be a dynamically typed language. Now, what do you mean by the statically typed? So statically typed languages means that there is a link. Okay, there is a link or there is a bond between my variables and the data types. Okay, so now first thing, data type. The word data type. What do you mean by the data type? We all know data means information. So the information that I am going to gather, what type of information that is? Is it a number? Is it a fractional number? Is it a whole number? Is it a single character? Is it a group of characters? Is it a true or false value? What kind of data I am going to gather, or what kind of information I am going to gather? That is what you mean by the term data type. So data is the information, type is the category of information that I am going to be getting. Now, variable. The other word what we use is a variable. So what exactly is a variable? A variable is a container. It is a container that is used to store the values. For example, water bottle. Water bottle is a container. What is the purpose? It is used to store the water. Is it a permanent storage? No, I'm going to use it. Right. So for that only I'm having my water bottles. So same way, my variables. Variables are containers inside which I am going to store the data that I am going to get from the user. Say for example, I'm going to create a mobile application, a game. Let us assume I'm going to create a game. So in that game, I want the name of the player who is playing, because I want to maintain a leaderboard. How many points each and every person who's playing the game, how many points they are securing. So for that, I want the name of the person who's going to play. So I have to ask the person, whoever is downloading my app, I have to ask, okay, what is your name? So he or she is going to type some information. So where am I going to store that and keep? I need a container to store that information. That container is my variable. That container is what my variable is. Same way, imagine my game is having lot of violence. So I think it is not suitable for every person. So let us keep an age limit. I'm saying only people who are above 15 years can play this game. So second thing what I'm going to do, as soon as the person downloads, I'm going to ask, okay, what is your age? So if they are giving a value which is greater than 15 or above, I will allow them to continue. Otherwise, I will say, so one message, sorry, you are not allowed to play the game, and close the app. That's it. So again, age is an information. So I need to store it and keep so that further I can make use of it in the program. So where to store and keep? In my variables. So that is the purpose of these two words. So data type refers to the type of information I'm going to gather, and variable is a container inside which I am going to store that information. Done. So now, in a statically typed programming language, there is always a relationship between the data type and the variable. There is a binding. That is, whenever you are going to create a variable, I want to create a variable. How to create a variable? I have to specify first the data type. That is, what kind of value I am planning to store inside that variable. I have to mention that first. I have to mention that, followed by a variable name. Variable name is my choice. I can give any name for a variable. Then equals to some value. Close it with a semicolon. So this is the generalized syntax that I will follow in all my statically typed language. No matter what programming language it is, syntax is same. This is generalized syntax. So this is how I have to create a variable. So there is always a binding between my data type and the variable name. Without giving the data type, I cannot make use of a variable because it will throw error. It will throw me an error. Why this is important is it is going to do a checking. My compiler is going to do a compilation. I told you my Java program is robust. So it is going to do a security check. Strongly typed language. So it is going to check the data that I'm going to give. Is it belonging to this data type or not? Suppose I am saying age. I am asking the person, okay, enter your age. So instead of giving me a number, the person is going to enter his name. Should I accept the data? No, it should not accept. Because I am expecting a number, I'm expecting an age, but that person is typing his name, which is a group of characters. So there is a mismatch. So it should not be accepting that value. It should throw an error. It should say, no, this is not what I am asking you for. So that is how the security check is done. So that is achieved because it is a statically typed. That's what I said. It's a strongly typed language. So there is a very strong binding between my data type and my variable name. Now, there is another type of programming language which is called as a dynamically typed language. Dynamically typed. So dynamically typed is a loosely coupled language. This is a strongly typed language. That is a loosely coupled language. So now what do you mean by this loosely coupled? That is, there is no binding. There is no binding between the data type and the variables. What is going to happen? Variable name equals to value. That's it. I can give any type of value to any variable, no restrictions at all. I can say like this, a is equal to 10. Yes, accept that. Same a is equal to 20.5. Yes, accept that also. Same a is equal to, I am saying Python. Yes, accept that also. So there is no restrictions at all. What type of value we are planning to store inside this variable? There is no checking. There is no restrictions. So that is what you mean by a dynamically typed language. So which is a loosely coupled language. So any programming language basically comes either in this category or inside this category. Right. Say for example, programming languages like C, C++, Java, or C#, all these things are statically typed programming languages. Statically typed programming languages. Now, programming language like JavaScript, Ruby, Python, all these things are dynamically typed language. All these are dynamically typed programming languages. So there is another perception they say. Generally, programming languages, okay, any programming languages falls under statically typed category. Any scripting languages falls under dynamically typed category. So scripting languages, programming languages. Please remember, both are not same. Both are not same. Yes, as I said yesterday, I will tell you the difference of that. Okay, Java is a programming language. JavaScript is a scripting language. So the name may be different, same. You know, this also has Java, that also has Java, but both are 100% not same. Both are very different. The purpose of each and every application is different. So statically typed languages are the programming languages. Dynamically typed languages are what we have as our scripting languages. Another thing you can say, statically typed languages are all compiler based languages. That is, your code is getting compiled into a binary form and then only it is getting executed. See, in C also what happens? C, C++, source code is getting converted into an object code and then only it is getting executed. So in Java and also in C Sharp, it is getting converted to a bytecode, then bytecode into an object code to see the output. So here, there is no direct running. It is always compiled into a file and then only it is getting executed. But all my dynamically typed language, all my scripting languages are interpreter based languages. There is no compilation, directly only execution. How does my interpreter work? You remember yesterday I told you, line by line execution. There is no compilation. Directly the program is going to get executed and you're going to see the output of it. So that is how my dynamically typed languages will be working. So please understand the difference between these two. So Java is a very secure language. It is a robust language. It is able to give the security at so many different levels. It is ensuring that my application doesn't crash so easily. Right. And another one thing, garbage collection. Robustness is also determined by another process which is called as garbage collection. So garbage collection in Java is automatic. It is taken care by my JVM. My Java virtual machine is in charge for my garbage collection. Now, first thing is, what is this garbage collection? As the word garbage suggests, unwanted things. So once a program is completed its execution, I may be creating so many functions, so many variables, objects. So different things I will be creating inside a program. So everything is going to occupy some memory space. Once the program is run, once the output is given, what will happen to all that memory space? The memory space has to be released back. Then only we can reuse it for something else. So who is in charge of releasing all this memory space? How will I get to know whether the program has completed its execution or is it still using that memory? So all these things is taken care by my JVM through the process of something called as garbage collection. And this process is an automatic process. The programmer is not going to do anything in this. He or she is not going to get involved in the process of garbage collection. Now, as I said, the previous programming language, when Java came, which was very popular in the market, that was our C++. So in C++, it is the programmer's responsibility for handling garbage collection. People who are, aware of that, you will know. We have one concept in C++ called as destructors. Destructors. So it is the programmer's responsibility to write the code for the destructors. So destructor will be called at the end of the program. That is as the last concept before the program is getting terminated. So that is handled by the programmer. But in Java, it is an automatic process. Again, we are enforcing the security. Okay, you take care of it. You do programmer don't have to do anything regarding that also. And people who are again familiar with the concept of C and C++, pointers. There is one very important concept in C and C++ which is called as pointers. So pointers means accessing the memory address directly. Accessing the memory address that is getting allocated for a variable. Okay, where is the data being stored in my system? That memory address itself I will be able to access. So when you get that memory address, you can do all sort of manipulations. You can modify the data without touching the variable. I can change the value of that variable because I know where it is getting stored. So directly using that address, I can manipulate the data. Now this concept has been removed. In Java, no pointers. You cannot access any memory at all. Again, my JVM, whatever it is, my JVM will do it. A programmer cannot directly access any data's memory. So again, another way of enforcing my security in Java is done with this help. So these are the important features of why my Java is so very popular. Architecture neutral, platform independent, it's a robust language, it's a portable language. Then what do you say? Yes, another some words. Yes, it's a high level programming language. And very importantly, it is a general purpose programming language. So general purpose. It is not that you can use Java only for this, only for this. No, it is a general purpose language. Say, for example, I want to create a desktop application. Now, what do you mean by desktop? We can also call it as a standalone application. That is program or software that is going to get installed independently in each and every person's laptop. For example, I have an antivirus. I want to develop an antivirus software. So if I install the antivirus in my system, will all of you get it? No, right? So you have to individually install it in your system and activate it using some product key or a license key. So that type of applications, standalone applications, independent applications. Yes, I can use Java and create it. So, when we are having our systems, whenever we have a desktop or a laptop, we have lot of accessories here. We have a calculator, we have a notepad, we have some other features, sticky note, like that. Lot of different apps are given. All those are standalone applications. So all those can be created using Java. Yes, I can work on it. Now go to the next category. Okay, this is standalone application. Next category, web application. I want to create a banking application, a very high level, let us say a stock exchange, like that level of application. Yes, I can use Java over there also. So any type of web application, let it be a small web page. I have the concept of servlets. I have the concept of JSP, JSF. So many different categories are there using which I can use my web applications also. All are inbuilt in Java. One of the primary advantages of Java is everything is inbuilt. When you talk about Python, in Python, when I want to create a web application, I cannot directly use Python. I have to use any framework. I have to go for Django or any frameworks, which is not exclusively a part of Python. It's an added feature. But in Java, everything is inbuilt. I have the concept of servlets. I have the concept of JSP. Everything is part of my core Java itself. So that is another advantage I get. Any enterprise applications, that is a large scale application, e-commerce application, anything Java is superb. Java is very stable. So the stability, the scalability, because of that only people choose Java. So, okay, desktop application, standalone, yes. Web application, e-commerce, enterprise application, yes. Coming to the field of mobile apps, very, very common. Now you can't see even one single person without a mobile phone. So when I'm talking about a mobile application, we can have a basic mobile that is without your touch and other things. What we used to have, it is still there, used by so many people. That is also created using Java. Symbian operating system, your Java ME, we call it as Java Micro Edition. Using that, you can create apps for our basic mobiles. That is there. Android, all our phones, Android phones. Again, what technology we use? We use Java technology in creating any Android applications. So Android is the top one because it is very user friendly and it is also affordable. So everything is most of us, 99% of us have an Android phone. So again, Java, that is the reason I'm saying it is a general purpose application. Okay, I'm talking about any database connectivity. Yes, I can use Java there also. I have the concept of JDBC, Java Database Connectivity. So that is used to connect my front end and back end, my tables, my rows, columns, manipulations, everything I can do there also. So I want to go for a cloud application. I want to use my AI, big data. Big data technology is very booming. Again, you have the Hadoop. Hadoop is completely Java based. So like that, no matter what you're going, which field you're going, so Java is a general purpose application. So that is another key feature of my Java. And of course, multi-threading. multi-threading. Multi-threading applications, multi-threaded application, or we can call it as a multitasking application. So using Java, I can create softwares which can perform multiple jobs concurrently. That is doing multiple tasks simultaneously. So you can create applications with these features also if you are developing the program with Java. For example, a very simple, application I can tell you. Let us say you're going to write an online exam. So for an online exam, you have a user interface. So where they'll say, okay, you have a start button. Okay, start the exam. Then when you start the exam, the question, then A, B, C, D options are given. Then you can see on the top a timer. A timer is running. So no matter whether you go to the next question or not, the timer is a separate process. It will keep on running. Whether you are staying in the same question or whether you're moving to the next question. So the timer is a separate process which is going to run. You clicking the next buttons, previous buttons, that is one separate process which is keeping running. So like that, multitasking application. So using a Java code, using a Java programming language, I can create such type of applications. So a classic example of multitasking is our system, is our operating system. For example, your laptop, I am having concurrently multiple things are running in my laptop. If I want, I can put a background song. I can connect to a printer. I can give some pages for printing. So all the works is going to be done simultaneously. So you can create applications like that. That is what the purpose of multi-threading is. Each and every task is done as a thread. Each and every task will be taken care by one thread. And this entire thing together will be a process. So multi-threading process is done. So that is another thing which is supported with my Java. Then of course, we have the OOPS. Major, very important is our OOPS, object-oriented programming. So under this concept of OOPS, I already told you, OOPS is just a concept. OOPS is nothing but a set of concepts. So what does the OOPS say? You follow these concepts and develop your applications. That will gain some benefits. So what are the OOPS concepts we have? We have something called as classes, objects, abstraction, encapsulation. Then you have something called as inheritance. Then of course, the last of the OOPS concept, polymorphism. So these concepts together is what we have the thing as object-oriented programming. So in Java, you have all of these concepts. You have all of these concepts. So hence, Java is a OOPS language or an object-oriented programming language. Now, please remember, there are two things. Object-oriented programming languages, object-based programming languages. So object-oriented is different, object-based is different. So object-based programming language means it will not support all of these features. It will not have support for all of these features. That is, direct support will not be there. Indirectly, I may be using the concepts, but direct support is not there, especially for concepts like inheritance and polymorphism. So object-based is different, object-oriented is different. Java, C++, C#, all are object-oriented programming languages. JavaScript is an object-based programming language. Okay, so again, a small difference. As I said, once we complete our OOPS, once I discuss about all these concepts, I will tell you how to differentiate or what are the differences that is there with your between your Java and your JavaScript.